Good afternoon, students. How are you today?
Afternoon, sir.
Right. I thought I'd have seen the whole class turn out, but clearly some students have already done their exams. All right. I am unfortunately driving home, and um, I'm thinking or hoping to be about 20 minutes away. Actually, I'm on the highway. So what I'm going to ask you to do for me in the meantime, and hopefully it will give those latecomers an opportunity to come in. I'm moving on to something new this afternoon. When I would have gotten home and settled in. Do me a favor, can you just do some revision for me in the meantime? I don't know how much data I have, but I'm going to try and keep the phone on. Holding the phone in my hand. Listening out, so just do some work for me, please, in the interim. When I come back, I'm going to be starting one of two things. Either the integration of some logarithmic function, or I'm going to start the first order differential equations. So I will decide which one I'm going to start when I get back. I'm approaching the toll plaza now, so I soon talk to you. All right?
Okay, sir.
Mm-hmm.
Good night, Mr. Shan.
Good night, Kirito. How you doing? I'm hustling to reach home. I'm almost there. A bit between another 5 minutes. I'm just hustling to reach in. Night was some fun.
Good evening, everyone.
Good evening, Andrew.
All right, guys. All right, so thanks for your patience. There's still only just 12 of us here. And let us see if we can hit the, no, not 12 of us, 11 of us. Let us see if we can hit 4. And again, I apologize. I went doing road today and got caught up. All right, with that said, I will just go ahead and begin my first order differential equations. The topic for last class is a must-have for the exam, your implicit differentiation. And I'm going to put a question for between 5 and 7 marks for it. As I told you, in order to go up to do the tangent versus normal, so you have to be mindful of that. Be mindful of that, please. Share screen. All right, so we're going to be solving first order differential equations. One of the things that I see again happening is that they put a few of these questions on the exam paper. Really isn't a problem. I'm happy when they put it on it because it's not a bad topic. All right, so when we solve first order differential equations, and I call them FODE, we are going to be solving equations in the form dy by dx. Only in the form dy by dx. There are other questions, there are other types that they will give you, or that exist, won't give you, but exist. That includes d squared y by dx squared. Those are called second order differential equations. We won't do any second order differential equations. All we're going to be working on for this semester, or pre-calculus 1, are first order differential equations. Everything first order, we are going to be working on those. All right, so I want you to be alert because here goes. The general solution of a differential equation is of the form f dash of x is equal to f of x, or dy by dx is equal to y. And that can be found using direct integration. So what I'm saying to you is, when I solve a question, a first order differential equation, it means that I'm finding that using direct integration. I'm integrating. So this is a topic under integration. First order differential equations, I'm integrating. So the questions will come in the form f dash of x, and we need to write that equation in the form f of x, meaning that we need to integrate it. When we integrate it, we get back the original question. Or they may give it dy by dx, and when we integrate it, we're going to get y. All right, so we're not moving from differentiation y to dy by dx or f of x to f dash of x. We're moving in the opposite direction. Hear me out. I may say, Jamaica nice, you know, but one thing, the Jamaican man, them worthless. And some of you in the class may agree. Some of you may very well agree with me and say, it's true, sir, the Jamaican man, them worthless. And another few of you may say, sir, that's not true. And I say, sir, in what context? Because they don't take care of them pitney. And more students say, sure, sir, true. And then one or two may say, sir, that's not true. And why we say it's not true? Because their experience would have been different from somebody else's experience. They may or may not live with their father, but they have a close relationship with their father, or even as a close relationship with their father, but their father is a provider. So they may not live with the father, they may not have a relationship per se with the father, but the truth of the matter is, when bills to be paid, when this is done, the father is there. All right? But the other students now who will say, yeah man, the Jamaican man, them work is the truth, sir. Real talk that, sir. It may mean because those Jamaican fathers don't stand up to their responsibilities. You know, try as they may, you can't even get a dollar out of them. You know, etc., 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 etc. That's a generalized statement, incidentally. When we make a wholesale statement like that, it is a too general a statement for it to hold any weight. So we have to go to the specificity of it, right? And the specificity of it now is going to call a particular solution. The specificity of it is going to be called a particular solution. When you get down to the nitty-gritty, it's called a particular solution. So let us look at it. A general and particular solutions. General and particular solutions. It says find a particular solution of a differential equation dy by dx is equal to 4x minus 2. I'm expecting questions of this nature. I'm expecting questions of this nature for the exam to come. It says, given y equals 5, when x equals 3. Given y equals 5, when x equals 3. So we need to find a particular solution. But before we can find a particular solution, we have to first find the general solution. We have to first find a general solution, and then we go to the particular one. All right, so this question is going to be twofold. Fold 1 is to find the general solution. Fold 2 is to find a particular solution. Now, please note that conditions must be given for you to evaluate a particular solution. Otherwise, you can only determine a general solution. Let me just press pause right here and refresh your memories. When we're integrating an indefinite integral, what must happen in our final answer? When we're integrating an indefinite integral, what must you have?
Repeat, sir.
When you're integrating an indefinite integral, how does your answer look when you integrate an indefinite integral? What must it contain? A fraction. All indefinite integrals must have one thing in common. They contain a what?
Sir, they must have upper and lower limit.
No man, that's the definite integral, you know. That one is a definite integral. When you integrate in a function, the one that don't have no upper limit and lower limit is what we call indefinite integral. When we integrate in an indefinite integral, and when we get our answer, what our answer will look like?
The unit square thing, sir.
The unit squares only come when you are doing the definite integral. The unit squares only come when you're doing the definite integral. Think about it, man. You know hard, you know, we do this long time and it means no.
Is the plus C you talk about?
Yes, man. That me I talk about. Thanks. It must contain a plus C. And that's a constant of integration. No, we're trying to work backwards we get no. So that's why the conditions are very important. So every indefinite integral will have a constant of integration because there's something else about it that you don't know. You must be given more information in order to decipher what it is. All right, let's go. Let's just look at this. So let me do this. So look at the question. The question says dy by dx is equal to 4x plus 2. And it asks me to find a particular solution of the differential equation. Now, I must first find a general solution. And then from the general solution, I'm going to find a particular solution. So I must first find the general solution. All right? Now, I'm going to be integrating. But before I integrate, I need to do something to the function. My dy by dx, which is up here, my dy by dx, which is equal to 4x minus 2, right here. I'm going to put the same dy by dx is equal to the same 4x minus 2, but I'm just going to put it over 1. I'm going to put it over 1. And then what I'm going to say is, remember that when you have two fractions separated by an equal sign, you are going to cross multiply. Whenever you have two fractions separated by an equal sign, you always cross multiply every single time, not only today, yesterday, today, and tomorrow. Whenever you have a fraction, two fractions separated by an equal sign, you always cross multiply. All right, work with me. So dy by dx is equal to 4x minus 2 all over 1. This dy is going to multiply by the 1, so I'm going to have dy. And this dx is going to multiply by the 4x minus 2. So I'm going to have 4x minus 2 times dx. Now, I would have separated my variables in such a way that all my y's on one side and all my x's on one side. But sir, not seeing any y there? Yeah, man. The y is corresponding to the 1. And the x is corresponding to my 4x minus 2. X is corresponding to my 4x minus 2. All right? So I'm integrating. Now, when I integrate dy, remember, the integral of 1, written simply as dx, not 1 dx, is going to be x plus c. It's going to be x plus c. And remember that the constants of integration must be included in the final answer, which is a question I was asking earlier. The constant of integration must be included in the final answer. So when I integrate dy, I'm going to get, well, I'm not telling you what I'm getting here. So what I'm doing here, I'm integrating here. Well, I can tell you, when I integrate dy, I'm going to get y. When I integrate dx, I'm going to get x. When I integrate dr, I get r. dq, I get q. All right? So I'm integrating my function dx, and I'm also integrating 4x minus 2. Watch me. Come on now. So I'm going to have the integral of y, the integral of dy is going to be y. And when I'm integrating 4x, it's going to be 4x squared over 2. See here? 4x squared over 2. And then this minus 2 is going to be minus 2x. See here? Minus 2x plus c. I must include my constants of integration. And you recognize that 2 can go into 42 times. I have 2x squared minus 2x plus c. So this is my y. Remember, I said to you that when you're doing your differential equation, it's going to be of the form y, it's going to be of the form f of x, f dash of x is going to be equal to f of x. It means that you have the first derivative and you are going to integrate it in order to get the original function, right? So they can give you either in f dash of x to be equal to f of x, or they can give you as dy by dx. And when you work it out, you're going to get it in terms of y, all right? So continuing, when I integrate, I'm going to have, so this here is my general solution. So the general solution is going to be y equals 2x squared minus 2x plus c. Let us look at the particular solution now. The particular solution says given y equals 5 when x equals 3. So when y of 5, x will be equals to 3. So sit here, recall y is 5, x equals 3. Anywhere in the function I see y, I put 5. Anywhere in the function I see x, I put 3. So this is going to become 2 times 3 squares minus 2 times 3 plus c. And that is that 5. 3 squares is 9, 2 nines are 18. Negative 2 times 3 is negative 6 plus c. 18 minus 6 is going to be 12. 12 plus c. I'm subtracting 12 from both sides. So I'm going to have 5 minus 12 is equal to c. And c is going to be equal to negative 7. C is going to be equal to negative 7. So all I'm doing is substituting the value of c now into my general solution in order to get my particular solution. So it's going to be y equals 2x squared minus 2x minus 7. And this is my final answer. And that is my final answer. Talk to me now. What are you not seeing?
Sir, go back up a bit.
Top part, sir. Go back over again, sir.
Yeah, stop. There's a look a bit. Oh, we reach at the 24.
Originally 24 is not, it's not 24. It's actually 2 into 4 goes 2 times.
Oh, that is what was confusing me.
Yeah, me too.
Come here, I wonder what we'll get 24 from if I miss something.
24 goes 2 times. Alrighty, so let's go again. So you're given a question. It says, find the particular solution of the differential equation dy by dx is equal to 4x minus 2, given y equals 5 and x equals 3. A question like this is about a 5 mark, you know. Depending on the function, if the function was a little uglier, it will be a 10 marker. But they can give you 2 of these questions, 2 different types, and them charge you 7 marks each. 2 different types and they charge you 7 marks each. So be prepared. I'm actually expecting something resembling this come whenever you do your exam. All right, let's go. So it says, find a particular solution of the differential equation dy by dx is equal to 4x minus 2. Before I can find a particular solution, I must find a general solution. They're not going to tell you this in the question. They won't tell you this in the question. You can't go ahead and find the general solution first without finding the particular solution. So be very careful.
I mean other way around.
They can't find the particular solution without finding the general solution.
There we go.
Beautiful, right? I said that to see if you're paying attention. All right, so thank you though. So what is happening here is that when you have your dy by dx and it's equal to 4x minus 2 over 1, what it is that I'm trying to do is to put all the x's together and all the y's together. I'm putting all the x's together and all the y's together. You know, we call them variable separable. So we're separating the variables so we can put all the x's together, y together. Because we can't integrate one function in x with, say, 3y plus 2. No, the function say x. You can't do it y. You have to do x with x and y with y. Can't work. So I'm going to be separating my variables. So what is happening here is that I'm creating a fraction. 4x minus 2, if I divide it by 1, will not change the fact that it is still 4x minus 2. It will not change it that it is still 4x minus 2. It will always be 4x minus 2. When I divide by 1, it is an identity. I get back the same result. All right, so I have 2 fractions separated by an equal sign. I cross multiply. 2 fractions separated by an equal sign, I cross multiply. Every single time. 2 fractions separated by an equal sign, I cross multiply every single time. So it's going to be dy times 1 is going to be equal to dy. And 4x minus 2 times dx is going to be just that, 4x minus 2 times dx. You notice that I have all the y's on one side. So I'm not seeing any why you keep saying that. There is a 1 there. Remember, the integral of 1, written simply as dx, not 1 dx, is the integral of dx is going to be equal to x plus c. All right. So when I integrate my dy, I'm going to get y. And when I integrate 4x, I'm going to have 4x squares minus 2x. I'm going to have 4x squared minus 2x plus c. Remember, the constant of integration must be included in the final answer. So why? It's an indefinite integral. You're not seeing an upper limit nor a lower limit. No upper limit, no lower limit. They are indefinite integrals. So I must include my constant of integration every single time. So y is equals to 4x squared over 2, and this is minus 2x plus c. The 2 cancels into itself, goes 1 time, and the 2 into 4 cancels, goes 2 times. So I'm going to have 2x squared minus 2x plus c. So we always put plus c, yep. If it is a negative sign, when you put in your conditions, the negative sign will come out, like in this case. Right, so that's my general solution. And the particular solution now says when y, given y equals 5, when x equals 3. So anywhere in the function I see y, I'm putting 5. And anywhere in the function I see x, I put 3. And we substitute and we solve, we get the correct c equals -7. And then we're going to substitute into our function. And this is the original function. This is the general equation that you would have found. Any questions? Háblame, háblame.
Sir, repeat the specific part.
Repeat the what?
You said the general solution, the particular solution, sorry, the particular solution. Repeat that part.
The particular solution says, it says when y is 5, sorry, given y is 5, when x equals 3, anywhere in the general solution you see y, you're going to put 5, and anywhere you see x, you're going to put 3. So this becomes y, which is 5, is equals to 2 times 3 squares, right here, minus 2 times 3 plus c.
Okay.
So what? So I have an equation in C. This is 5. 3 squares are 9. 9 times 2, 18. 2 times 3 is 6. This is minus 6 plus c. 18 minus 6 is 12 plus c. I'm subtracting 12 from both sides. I'm going to have 5 minus 12 equals c. C is equal to -7. C is equal to -7. And my particular solution is going to be all of that. All right. I'm giving you a question here. I'm going to give you 5 minutes to work on this. Well, not 5, not so much as me, that's 5. I give you 3 minutes to work on this question. The question is in red, but I'm leaving my workout on screen so that it can be guided.
Good evening, sir.
Hello, how are you?
Lost.
You're not the only one. I expect you guys to be lost. You don't have come to class.
And it's unavoidable.
What am I looking at? Okay.
Sir, before you show us the questions, go back down to your answer, to the one that you just showed us. Or say you just skip out.
Yeah, right. I keep the general solution and only make the substitution for C.
No.
But I don't want to do the substitution part yet. I just want to get the general solution. All right, see the question there. See if we can start that for me, please. Look at what is happening here, Sash, and see if we can manipulate this one here. I'm stepping away for just 2 seconds and then come back. By the time I'm back, we're supposed to be finished.
That's the question, sir.
What's the question?
See the question here? The question is in red. So it's the same thing. So what should happen is just that I don't want. All right, you know what I do? Is that let me reduce it.
Now. Let
me reduce it. I want to project the question in such a way that you can see the solution.
Just a little.
So see, it will be find the particular solution of the differential equation And instead of using that one, you're going to use the one in red. You're going to use this one, and then I'll give you the conditions. You know what? I can put the conditions there. Given y equals that. Copy. Yeah. So that's the question. Find a particular solution of the differential equation, and then that. So I just want to start, and let me see how. Oh, I can translate. Okay. How are we? Are we okay?
Yes, sir.
Yes, sir.
Got the general solution? What is it?
Yes, sir. Y equal x cubed minus x plus c.
That's what I got as well.
That's it? Oh, yeah,
Yes,
right
sir.
here. All right, no. And the specific, the general solution, the particular solution now is that given y equals 2, x equals -1, would have gotten or c to be equal to 2, don't it?
Yes, sir.
Very nice.
Yes, sir.
Very nice, very nice. What about the others? All right. So one more here, example 3 for me. Run that. Very nice.
I feel lost. Good no.
Let me go through the rest of you. Just take off the function for me, please. So I can just go through the second question, second example. Let me know when you finish so I can move on. Can I move?
Sure. One part me never really get how it turn x cube in me have x squared, but me realize it's actually x cube.
Yeah, add 1 to the power and divide by the new power.
Oh.
You're integrating.
All right, sir.
Mm-hmm.
I'm finished, sir. I don't know if anybody else finished taking it off.
Mm-hmm. All right, so let's go. For those of you who are not seeing, so the question says find a particular solution of the differential equation dy by dx is equal to 3x squared minus 1, given y equals 2 when x is equal to -1. Given y equals 2 when x is equal to -1. So I'm going to put my dy by dx is equal to 3x squared minus 1 and put all of that over 1. I'm actually trying to separate my variables. What do you mean by that, sir? Put the x them together and put the y them together. All the x's go with each other. All the y's go with each other. The x's go together and the y's go together. The x's go together and the y's go together. All right. So when I do that, I'm going to be cross multiplying. Once I have a fraction, 2 fractions for that matter, separated by an equal sign, I always cross multiply. dy times 1 is going to be dy, and dx times 3x squared minus 1 is going to be 3x squared minus 1 times dx. All right. And then now I'm going to be, well, before I integrate, I'm going to look at it to see that all of this is my x. But sir, this is plus 1, yeah. This is minus 1, yeah. This minus 1 is already married to the 3x squared. So it is 3x squared minus 1. So all of this is relating to x. So now that I see this, I can now go ahead and integrate this. Remember, the integral of 1, simply written as d of x or dy, is going to be y. So when I integrate this, I'm going to get y. So this is a y. When I integrate my 3x squares, it's going to add 1 to the power, divide by the new power, 3x cubed over 3. And this is going to be minus x. When I integrate negative 1, I'm going to get minus x plus c. The 3's cancel, so I'm just left with x cubed minus x plus c as my general solution. As my general solution. Recall.
No, sir.
Nice job. And recall, when y is equal to 2, x is equal to negative 1, wherever in the function, the general equation, the general solution, you see y, you're going to put 2, and wherever you see x, you're going to put negative 1. So that is going to be 2 is equals to negative 1 cubed minus a minus 1 plus c, and negative 1 cubed is going to be a negative 1. And a negative 1 times a negative 1 is a positive 1. So those two cancel, plus c. So c is going to be equal to 2. So I'm going to go back to my general solution and substitute the value of c there so that I now have y squared y is equal to x cubed minus x minus 2. Let me just show you a quick thing. I don't know if anybody figured it out yet, but in the interest of time, let me show you. Differentiate this function for me, please. Talk it out to me. When you differentiate y equals x cubed minus x plus 2, what do you get?
3x squared minus 1, sir.
Sir, dy by dx is equal to 3x squared minus 1. Right up here, so right in this. Dy by dx is equal to 3x squared minus 1. Differentiate this and what you get.
So you want me to?
4x
What is
minus 2.
4x minus
4x dy by dx is equal to 4x minus 2. Teacher, sir, dy by dx is equal to 4x minus 2. So that's all you do. You just call differential equations. You're just trying to be working backwards.
So when I have to work it, when I can't just write the answer.
Oh, you're gonna know the answer. Them now give the function y, you have to go find y. That's the problem. What you must say to me is that when you get to y, you can double check your answer.
That makes sense.
Mm-hmm. All right, there goes number 3. Let me see if I have a fourth one there. And do I have a fifth one? Do I have a sixth one? Yes, I think I generated enough. All right, continue working, please. 3 more minutes. Oh.
Sir. Sir.
Anybody finish this one?
Yes, sir, but I don't know if you're right, sir.
No problem.
Sir.
Mm.
So me I talk to you now, answer me. I know you have me on the manners already, I'm malice already, you know, but you have to go answer.
Well, it's not your one really, but no, but I had gotten up. I went out at something. Go ahead. No, what you got? What was the question?
It may be a stupid question, but I'm just concreting it in my head. When for this particular question, the first step you do is to put that equation, what follows dy by dx over 1.
The first thing you're trying to do is separate the variables, put all the x's together and all the y's together.
Yes, sir. I know that language. Me I talk about the simple language where it go stick in my head. I know how I saw it for go. Okay. All right. Thank you very much.
Okay. Yeah, what's the answer now, Charlene? You say you don't know it right?
I have 21x to the 4th over 4 minus 4x cubed over 3 minus 5x plus c.
Yeah, so wrong actually. Why get 21?
Repeat, sir.
Say stop,
Oh,
sir.
I get it right.
Can they say stop, sir?
No, that's the
No.
general solution, Sasha.
That's the general solution.
Okay.
Sir, wrong place today, sir.
Yeah, some realize.
Oh, yeah, give me heart attack. Give me a sec.
No,
Okay.
there's more. No, if I just the first, when you start trying to find y, if that's where you stop and then you replace.
Right.
Yeah.
I want to see how you get the 21 though, Charles. Tell me how you get 21. Look at what I have and see.
Yeah, basically, you can leave it with the fractions.
Differentiation, you know.
She differentiate, sir. Because it look like she saw both the integration and the differentiation. So instead of minus, she plus.
Yeah.
Oh no, differentiation should go straight.
Yes, differentiation should go straight. So Charlene, honey bunches, you have to integrate here. And anybody who made that mistake, integration. Right, so make that correction for me, please, and then let us move into some other stuff.
Sir, this look like substitution now, don't sir? So is it a case where you're going to write back y equals 7x to the fourth minus over 4 minus 2x cubed over 3 minus 5x plus negative, is it -1, sir? Oh my God.
All right, sir, so I have a question now that you reveal that. Is it safe to assume that once x is equal to 0, c is going to be y? Okay.
Not bad.
The rest of you? Let me see. Yes, let me see. Let me see how many of you will get this one. There's not even a trick to this, but let me see how you do it. Try that one for me. I don't expect you guys to get it, and if you don't, I am not going to be upset. But try it.
Sure, what a gradient something there go. Mx plus c, that's a gradient?
Yeah.
There are too much letters that.
So, sir, I remember.
Try it, man. Hello. Chide something. Chide.
Sorry, I might try it and it choke you.
Careful now.
I didn't say anything. I just said, man, it choke you.
Careful now.
So, sir, what you do with the 3?
You know, look at the question. Just think about it. Think about it in the scheme of the things that we have been doing. Think about it in light of all that we have been doing tonight.
Oh, tonight. Well, I don't know what you do before this.
The same something you had. Where we do before this are the same something you don't know.
So correct me again. Y equal mx plus c, sir?
What?
That's the gradient, the straight line.
Why is it mx plus c? Yeah.
Sir, which question are we doing now?
Numero
Number
4.
Okay.
Nobody finish it?
I may try some.
Sir, wrong and strong. Y equal 3x minus 7.
Y equals 3x minus 7. I don't want. All right, let me just stop share and then check my answer.
So you don't want to slip.
How you did that question?
All right, so I used the equation of a straight line to work it, and gave us the gradient, which would have been the number beside the x, and from there, x is 2 and y is -1, so I solve for c.
You're correct.
Yeah, something like that, may I do, you know?
You're correct, but why I asked you how you do it, because that's why I said to Sash, let us look at it in the same light like what we've been doing tonight. So if you gave me that as your answer, I would mark it right. It will be right, but let us look at it in light of the differential equation. It says that the gradient is 3. So dy by dx is a gradient, don't it?
Yeah, come here, say nothing else can go there.
Right, so dy by dx is equals to 3. So now you have two fractions, put this 3 over 1, you have two fractions separate by an equals and a cross multiply. The dy times the imaginary one only has to give dy, and 3 times dx is 3 dx. And then you integrate this now. And then get y equals 3x plus c, that's the general solution. And then you use this now where x is 2 and y is -1 into the function and get your -7. So your particular solution is going to be y equals 3x minus 7. The other method,
God.
Yeah, it's really not bad. It's the same thing. So if you use y equals mx plus c and do like what you need, you still get the same answer. But I'm just saying, in differential equation, you still could also do it this way, the same method that we have been using in order to get what it is that we have gotten right there. Same thing. I just look up at the clock and recognize it's 6 minutes past 7, and I want to be responsible with your other class.
You're in another class.
Yeah.
Yeah, seriously, we don't have no class.
Yeah, but 3x minus 7 is the correct answer. I want you to all look at that one for me. And since you don't have it in the class and want to start from class, let me just end off with number 5. So when we do number 5, we'll end up in the class. Look at me. I am projecting another question for those of you who have completed number 4. But for those of you who still need to look at number 4, I'm leaving it up. I'm leaving up number 4.
Finito.
And what's the answer?
Y equal x to the 5th over 5 plus 2x squared over 2 plus 1.
Minus 1. Minus x.
Huh?
Minus x.
So it's actually supposed to be.
Are you giving the final answer?
Yes, sir.
Okay, yeah. I thought it was a general solution.
Hold on.
But you know of the minus x too, sir.
Mm-hmm. You should have a minus x here.
Where that comes from?
The negative one.
There's a negative one. When you integrate the negative one, you're supposed to get negative x.
Mm-hmm.
Sir, for the general
yeah.
For the general solution, sir, I canceled out the 2x squared.
Fair enough.
Okay, sir.
Same difference. You'd have gotten x to the 5th. Matter of fact, you could have written 1/5 x to the 5th plus x squared minus x plus c. Yeah, man, same difference.
So, sir, you mean leave out the x minus x with a wrong?
Wrong.
The answer wrong. That's two different functions that you know. But then, but you won't get 0, 0, 0, 0. Somebody has to say our mistake you make, but it wrong still doing you know. Yeah, man.
All right, sir. Whenever the one, we need to focus on the one.
Mm-hmm. All right. Very good. I'm going to end here. Very good. I hope you guys are accessing the recordings that I'm waiting patiently to be sent to me. Sometimes they come quickly, sometimes they don't. So as soon as they come, I will send them out. But keep reminding me, because next they come out and I miss them. But we will talk on Thursday. I'm hoping that I can finish the other forms of the variable separable. This is the easiest of the 1, 2, 3, 4 cases, and we can take it from there. So I'll see you on Thursday. All being well.
All being well.
All right, sir.
Take care, man.
All right, sir.
Good night, sir.
Sir gone?